Hello everyone and welcome to this hypothesis testing for the mean standard deviation known, i.e. z-test, part 3 where we will go over the last type of problem or last type of conclusion we will see when it comes to hypothesis testing. So let's jump right into. An instructor claims that the average score claims for their statistics exam for their class is greater than a 65. In a sample of 20 students, the average exam score was 68. Assume the population is normally distributed with a standard deviation of 10 points. Can you support the instructor's claim with a level of confidence 0.10? What's the question here? The question is, can I support the instructor's claim? So what do we need to test? We need to test the instructor's claim. Well, what's the instructor's claim? Their claim is that the average, mu, is greater than 65. So mu is greater than 65. What else does my problem tell me? It says we look at a sample size of 20 students, so n is 20. We find that their average score was 68, so x bar is 68, and that the population standard deviation is 10 points. And now we need to perform our hypothesis test. First step, state your null and alternative hypotheses. First, what type of hypothesis is your claim? Well, it doesn't include an equal sign, which means it is a alternative hypothesis. So H sub A is that U is greater than 65. Well, what does that make your H naught? What's the opposite of greater than? Less than or equal to. So H naught is that mu is less than or equal to 65. The H sub A, the alternative hypothesis, is the claim. It's a greater than statement, which means we are working with a right-tailed test. Let's draw a picture of that. When we are working with a right-tailed test, that means we have our normal distribution and our rejection region is on the right, and it has some cutoff positive critical value. What do we know about that critical value? We know that alpha is its area. Alpha, area. Alpha is level of confidence. We know that the level of confidence we're looking at is 0.10. So what do we know? We know that the area to the right of our critical value is 0.10. And how many decimals do we round area to? 4. So I'm going to add 2 more decimals there. But I don't know anything about area to the right. But I do know that area to the right of z is equivalent to area to the left of negative z. So area to the left of negative z is 0.100. When I have area to the left in a critical value, what should I think? I should think, go to my chart. So we go to our chart and we'll find that the critical value that corresponds to this area is negative 1.28. But that's negative critical value. What do we care about? We care about our positive critical value. Our positive critical value then is positive 1.28. And so where does our rejection region at? It's greater than our critical value. So if our z is greater than 1.28, what are we going to do? We are going to reject our null hypothesis. Okay, so what is our z value? Let's find out. Z is equal to sample mean 68 minus population mean 65 divided by population standard deviation 10 divided by the square root of our sample size, which is 20. If you plug that into our calculator, you will get 1.34. Where does that lie in our normal distribution? Well, that's greater than 1.28. So it's in our rejection region, which means we reject the null hypothesis. Okay, great. I reject my null hypothesis, but what did I care about? I care about the claim. What was my claim? My claim was the alternative. If I can reject the opposite, then I can support my claim. Okay, the way I explained it in class was if I can say there's only 2 colors in the world, red and blue, and I say, well, it's definitely not red, then that supports the idea that it's blue. Now, again, there's some error there. Maybe the light's hitting my eye at a different light speed or whatever determines color, wavelength, right? That thing. Okay, maybe that's the case. So maybe I'm still off. But in general, if I say, okay, it's definitely not red and the only two colors are red and blue, then it's definitely blue. And so what we're saying is it's definitely not H naught. We can reject H naught. So what does that tell me about the alternative? Well, that means we can support the alternative. So what's our conclusion? We say there is enough evidence at alpha equals 0.10 to support the instructor's claim or the teacher's claim. The instructor's claim that the test average or the exam average, maybe specify statistics exam just to stay consistent, exam average is greater than 68 or 65, excuse me. It's greater than 65. And that is our conclusion. That's our answer to this problem. It asks, can you support it? Yeah, we can. In fact, we have this data that says there's enough evidence at this level of significance to support the instructor's claim. So that is all. Those are our three different options, okay? So go back, read through those, notice those three different options, notice the wording. This next lecture video, we're going to do the exact same thing with one little tweak. So go ahead and move on to our next set of lecture videos.